explosive. So the observation, it was a very interesting observation. When the chicken soup was added to the soil, there was a chemical reaction almost immediately, and gases were released. And the same types of gases that you would expect microbes to produce if they were present. That was interesting and exciting.
Yeah.
The problem was that the rate at which those gases were released was odd, was way too fast, almost instantaneous. If you expected microbes to be present, they should take their time to come back up alive and eat their things and then eventually release those gases. So that was odd. The other odd thing is that part of the experiment was to scoop out another sample of soil and heat it up to very high temperatures to kill everything that might have been living there, and then add the chicken soup. If the original reaction was due to biology, we shouldn't see a reaction in the second case.
Right, because you would have killed
everybody was dead. And what happened was quite the opposite. They added the chicken soup to the dead sample, and there was a reaction similar to the first one, suggesting that whatever was causing the reaction was not a microbe.
Shoot.
Yes.
That must have been crazy. You sent your experiment on a rover to Mars, and it gets there, and it does its thing, and you're not sure.
And you're not sure. I mean, you never know. Maybe they didn't like the soup.
Yeah, well, maybe that's it. They like tomato soup, you know?
But definitely the experiment was very interesting, very inconclusive.
Right. So then what?
Well, it was clear from Viking that maybe our thinking about searching for life at that time was a bit naive, because we really didn't know much about Mars until Viking went to Mars. Now, hindsight is always 20/20. So with what we know now, we might think it was naive. At the time, it was probably a very smart thing to do.
Yeah. Well, we hadn't been there yet.
We hadn't been there yet. So, but what followed up after Viking was a realization that when next time we search for life, we might want to know in advance a bit more about the planet, what conditions are there, and what the history of the planet was. And so a lot of the follow-up missions tried to bridge that gap, that knowledge gap, understand what happened to Mars over the course of its history, how it became the extremely dry, extremely cold planet that it is today, and maybe try to understand if life was present at some point, whether it could still be there, maybe in other places, or maybe the chances of life surviving throughout Mars's history were pretty much zero.
Yeah. How'd you go from oceans to desert?
Deserts, exactly, and how does life react to that?
Yeah.
So we've had a lot of robotic missions to Mars since then, right, Michael? What have we done over there?
Well, we've sent a lot of rovers to the surface now, and the latest one now is Curiosity. And that's going and actually collecting samples and driving around. It has a bunch of instruments. It has a drill on board for collecting samples. It has a laser for zapping rocks. So
I think we have a video of that, or an image. Right?
Yeah.
There we go.
Here's Curiosity. Yeah.
And the thing that personally excites me is that Curiosity has the ability to choose what it zaps with its laser, which is pretty neat.
It's exciting.
So
it's roving around, zapping stuff with a laser.
Yeah,
robots with lasers. What can possibly go wrong?
Excellent.
Yeah.
That's cool, and that's very cool for you, the roboticist who works on teaching robots.
They're getting progressively